Welcome to the deep dive. You know how it is you're trying to stay informed, but sometimes, wow, it just feels like drinking from a fire hose.
Yeah, totally. Information overload is real.
Exactly. So that's where we come in. We sift through the dense stuff, the regulations, the reports, and pull out the key bits, the things you really need to know.
Think of us as, I guess, your dedicated research partners. We're here to make the complicated stuff clearer. We go deep into the sources you give us, find the core ideas, and, connect the dots.
And today we're getting into something that sounds simple on the surface, but really isn't, especially with commercial spaceflight booming. We're talking debris and population exposure analyses.
Critical stuff.
This is episode 7 of our FSA pod, the Flight Safety Analysis series, really zeroing in on this. We've been looking at the FAA regs, 14 CFR Part 450, specifically Section 450.121 on debris analysis, and then the ideas around 450.123 flight safety limits.
Right. And for this deep dive, our sources are those regs 450.121, the concepts from 450.123, plus the advisory circular, AC 450.123, and importantly, the final rule preamble sections that talk about these specific rules.
So our mission today, basically to unpack how the FAA regulates the risk when things, well, fall down during launches and reentries.
How they manage debris and protect people on the ground.
Yeah, it seems intuitive, doesn't it? Rocket parts falling. Bad. But the way the FAA tackles this, the level of detail in the regulations, it's pretty complex. Way more than just hoping nothing falls in the wrong place.
Definitely. It's a rigorous process.
Okay, let's get into it. Let's start with that foundation, the debris analysis itself.
Right. Section 450.121. That's really the core of it. If you want a vehicle operator license under Part 450, you have to do a flight safety analysis, an FSA. And a huge piece of that FSA is this debris analysis required by 450.121.
Okay, so it's mandatory, not optional. What does it actually have to cover? What kind of debris are we talking about?
Well, it's pretty thorough. The analysis needs to account for basically every foreseeable cause of the vehicle breaking up.
Every foreseeable cause. So not just like a random engine failure?
Exactly. It covers everything from, component failures, structural issues, but also, crucially, it includes a breakup caused by activating the flight safety system, the FSS.
Ah, so even if you decide to terminate the flight for safety reasons, you still need to have analyzed where those pieces might go beforehand.
Precisely. Because that controlled destruction still creates debris. You need to understand the consequences of that action.
Makes sense. What else needs to be in that analysis?
It also has to look at the impact of an intact vehicle. If it just goes way off course but doesn't break up, that's still a hazard.
Right, a whole rocket hitting somewhere unexpected is definitely bad.
And this is a key point, clarified in the preamble to the final rule. It's not just about unexpected breakups. The analysis also has to include debris from, say, jettisoned components, things dropped intentionally during the mission.
Like spent stages.
Yeah, exactly. Spent stages, fairings, that sort of thing. And even the payload itself, potentially.
Okay, why the focus on things that are supposed to come off? Isn't that just part of the plan?
Well, the preamble explains the thinking. Even those normally jettisoned parts could pose a risk. They could hit an aircraft or maybe a ship if they land in the water.
Okay. Aircraft or ships.
Plus, there could be other hazards like toxic materials on board or fire risks associated with those components. So the FAA wants a full picture of everything that could potentially cause harm, not just pieces from a catastrophic failure.
Got it. So it's comprehensive, not just the dramatic explosion scenarios, but the whole life cycle of potential falling objects. That really shows the depth they require. Okay, now let's pivot a bit to flight safety limits. This is where I gather things changed a bit with the final rule. You mentioned 450.123 getting rolled into 450.108.
Yes, exactly. That's a really important shift to understand. Originally, there was a very prescriptive section, section 450.123, that laid out specific requirements for flight safety limits, how you had to define them.
Prescriptive, meaning step-by-step instructions.
Pretty much. But in the final rule, they moved away from that really rigid approach. They took the intent and the core requirements of 450.123 and integrated them into section 450.108, which covers flight abort requirements more broadly.
So 450.108 is the place to look now for how these limits work.
Correct. It's more performance-based now. The FAA tells operators what safety outcomes they need to achieve regarding flight limits and aborts, but gives them a bit more flexibility in how they demonstrate they meet those outcomes.
Okay, performance-based. So focusing on the what, not the how. What are these flight safety limits fundamentally for, then, under 450.108?
They're essentially the boundaries, the
Yeah.
operational envelope. If the flight goes outside these predefined limits, violating certain safety criteria, then a flight abort has to be initiated, either automatically or by command.
Like virtual guardrails for the rocket's flight path.
That's a good way to think about it, yeah. Guardrails.
And triggering an abort is obviously a big deal. What are the main goals that Section 450.108 sets for these limits?
Okay, so under 450.108, there are two main objectives. First, the limits have to make sure the flight operation complies with the overall safety criteria. Back in Section 450.101, the rule points to the specific parts of 450.101 that apply.
Right, connecting back to the basic safety rules.
And second, and this is really key, the limits must prevent debris that could cause a casualty from hitting an uncontrolled area if the vehicle goes outside the limits of a useful mission.
Okay, limits of a useful mission. That phrase sounds important. What does it actually mean in this context?
It's defined in the regs. Basically, it's the trajectory data and other parameters that define the intended mission performance. Things like the planned flight path, the target orbit, flight azimuth limits, those are defined over in Section 401.7.
So the plan.
The plan, exactly. And importantly, Section 450.109A3 clarifies that any data linked to a failure or malfunction is not considered part of a useful mission.
Ah, okay. So if things go wrong enough that you can't achieve the mission anymore, you're likely outside those useful mission limits.
That's the idea. The safety limits kick in to protect people on the ground when the mission itself is effectively over from a performance standpoint, and the vehicle is heading somewhere it shouldn't.
Makes sense. It's about managing the situation when things deviate significantly. What else goes into setting up these limits?
So Section 450.108(1) says you have to consider all reasonably foreseeable vehicle hazards. That means looking at what could go wrong during both normal flight and during malfunctions. You can't just plan for the perfect flight.
And actually making the decision to abort. That takes time, right? Data needs to come in, decisions made.
Absolutely. And the rules account for that. Section 450.108 requires operators to consider the potential loss of data needed to make that abort call, like losing telemetry.
If you lose the signal, you might not know you've crossed a limit.
Exactly. And subsection D4 specifically requires accounting for the time delay. Yeah. The entire delay, including uncertainties, from the moment a rule is broken until the FSS actually activates and has its effect. This relates back to an idea originally in the proposed Section 450.129 about time delay distribution.
Wow, so you have to factor in reaction time, system activation time, and the uncertainty around all of that. That sounds incredibly challenging to model.
It is. It adds a significant layer. You're not just tracking position, but predicting where it will be by the time you can react.
Now, what about the abort action itself? Is there a risk that triggering the FSS could actually make things worse somehow?
That's a critical consideration, and Section 450.108E is very clear. Initiating a flight abort must not increase the overall risk to the public.
So you have to weigh the risk of letting it continue versus the risk of the abort action itself.
Precisely. You wouldn't want the abort sequence to, say, direct debris towards a more populated area than if you let it fly a bit longer on its off-nominal path. It's a complex trade-off.
Okay. The outline also mentioned something about gating or relaxing these limits. How does that work?
Yeah, that's in Section 450.108. The idea is if your planned normal flight trajectory goes through a region where a flight safety limit would otherwise be triggered, but that normal trajectory has already been shown to meet the public risk criteria.
The criteria back in 450.101.
Right. Then you can essentially gate or temporarily relax that specific limit just for that part of the normal flight. It avoids forcing an unnecessary abort when the planned flight path itself is already deemed acceptably safe. It reflects the intent of what was proposed back in Section 450.125.
So it prevents the rules from being too restrictive in areas where the normal operation is already safe, practical.
Exactly.
And when an operator actually applies for their license, what do they need to show the FAA about these limits and abort rules?
Section 450.108 G2 spells it out. They need to describe how each limit and abort rule is evaluated and implemented. This means providing the quantitative criteria they'll use, identifying the critical flight parameters they're monitoring, and explaining exactly how they'll assess and act on data. to ensure debris doesn't hit uncontrolled areas if the vehicle goes outside those useful mission limits.
So show your work, basically. Explain the numbers and the logic.
Pretty much detail the whole system.
Okay, so we've covered the debris analysis under 450.121 and now the flight safety limits and abort rules under 450.1008. How do these two pieces really fit together in the big picture of the flight safety analysis?
Well, they're completely intertwined. You can't really do one without the other effectively. The debris analysis that detailed look at what pieces could be created, how big they are, how fast they travel, where they might spread under different failure scenarios.
Well, the stuff from 450.121.
Right. All that information directly feeds into setting meaningful flight safety limits and designing effective abort rules under 450.108. How can you set a boundary if you don't know what you're trying to contain?
Good point. The debris analysis tells you what the hazard could be, and the limits tell you when to act to prevent that hazard from reaching people.
Exactly. The consequence analysis from the debris side informs the thresholds on the safety limit side.
And how do these then help define those hazard areas you mentioned earlier?
Well, the output of both the debris analysis and the flight safety limit determination is crucial for defining the flight hazard areas, which are covered in Section 450.133.
Those are the areas on the ground or sea that need controlling.
Yes. Land, sea, airspace. Areas that might need warnings or controls like road closures or potentially even evacuation to manage public risk during a launch or re-entry. The debris predictions and the conditions that trigger aborts directly shape where those hazard areas need to be drawn.
And presumably, the chance of something going wrong factors in too.
Absolutely. The analysis isn't just deterministic. It has to consider the probability of vehicle failure, which is addressed in Section 450.131. And, as Section 450.133a states, the hazard area analysis needs to look at all reasonably foreseeable vehicle responses, normal and abnormal, that could lead to a casualty. It's a probabilistic risk assessment, fundamentally. Okay, it's all connected. Debris potential, failure likelihood, safety boundaries, hazard zones. Now, let's explicitly bring in the other key part of our topic. Population exposure. Where does that fit? It's woven throughout, really, but it comes into sharp focus in the debris risk analysis under Section 450.135. The whole point of that analysis is to show you meet the main safety criteria in Section 450.101, and a huge part of that is looking at the potential for debris hitting populated areas. So 450.135 is where they quantify the risk to people. Yes. It looks at the probability and consequences of debris impact specifically on populations. This can be done ahead of time, using flight commit criteria, basically, gonna-go conditions based on population data. Or it can even be done during the countdown, using the latest available data and the abort rules.
Dynamically assessing population risk right before launch.
Potentially, yes.
Yeah.
Using the best available information. And within that 450.135 analysis, there's a specific requirement for what's called a casualty area in consequence analysis.
Casualty area.
Right. It involves modeling the actual geographic footprint of potential debris impacts and calculating the expected consequences for people within that area. That's laid out in Section 450.135 B and D1. It's trying to estimate the potential human impact.
And this is where that point about uncertainty comes in, right? You mentioned the preamble earlier.
Yes, good point. The preamble discussion about not including uncertainty in certain calculations. That clarification specifically applies to this Section 450.135 risk assessment, not the Section 450.121 debris characterization itself. Different analyses, different requirements regarding uncertainty modeling.
Okay, that's an important distinction. So the main focus for population exposure risk related to debris is in 450.135. Are there other ways population exposure is considered?
There are. While debris impact is often the primary concern during flight, the regulations also address other potential hazards. For example, Section 450.137 requires analysis of far-field overpressure blast effects from potential explosions.
Noise and pressure waves.
Exactly. And Section 450.139 deals with toxic release hazard analysis, assessing risks from potential spills or releases of hazardous materials. So while debris is central to today's discussion, the FAA takes a wider view of potential impacts on populations.
Okay, that makes sense. It's a multifaceted safety approach.
Definitely.
So let's try and wrap this up. Key takeaways from this deep dive. It seems clear the FAA, through Part 450, demands really thorough analysis from operators, looking hard at potential debris, how it's created, where it might go.
Right. Under all sorts of conditions, normal and failure.
And then using that understanding to set up strict flight safety limits and abort rules, the guardrails we talked about, to actively prevent that debris from causing harm. It's proactive, not just reactive.
Absolutely.
Yeah.
And it's complex. Considers failure modes, trajectory deviation, system delays, uncertainties.
Yeah.
It's a deep analytical process.
And these pieces, the debris analysis and the safety limits, they aren't separate silos. They
Hmm.
feed each other, inform the hazard areas, and ultimately aim to meet those core public safety goals in 450.101.
That's the structure. A layered, data-driven approach to understand and mitigate risk to people on the ground.
So for you, the learner, hopefully this gives you a much better picture of the FAA's framework for managing these specific risks in commercial spaceflight. It's quite involved.
It really is.
And it leads to a pretty interesting thought, doesn't it? With launches getting more frequent, more diverse vehicles, different trajectories, how will these rules, these analysis methods for debris and population exposure, need to change or evolve in the future?
That's the big question, isn't it? How does the framework keep pace with the industry's innovation and scale?
Definitely something to think about. As always, we encourage you to check out the regulations themselves, 14 CFR Part 450, especially the sections we discussed, and the advisory circulars if you want the full, unvarnished details.
Yeah, the source material is always the best place for the complete picture.
Thanks for joining us for this exploration. Join us next time for another deep dive.